athletes. Whoop, whoop. All right. Watch my little screen swap in there. Okay, this is your warm-up today. Go ahead and do it. We'll talk about it. Pause me. I'm going to give you just a second. Ready, set, go. You might not even have to pause me on this one, right? Because what do we have right here? We have 3 minus 7 is -4. 2 negatives make a positive, so that becomes 10. 2 negatives make a positive. 15 plus 8 is 23. And 37 minus 48 is -11. Whoa. We got a bit of vocab to write in, so I'm going to switch to that page so you can pause it. Sorry, I didn't have those out for you. Oh. Go ahead, pause it. You need to write all these down. Okay, and then we're going to head on out. So make sure you pause it, wrote those down, and let's go back to our notes. We're talking about points, lines, and planes today. So you ready for this? You ready for this? Mark it down right here. This is a point. Now, a point in algebra has a value, right? It has a coordinate. This would be what? -2, 2. But this is a point. Then we have in algebra, we have a line. And lines in algebra has an equation. In fact, this would be y equals, let's see, it goes up, 2x plus 2, because it has a start value of 2. This is a line in algebra. And then this whole thing, believe it or not, is the plane. A plane is just a slice out of life, that flat surface, right? This would be a plane. Now in geometry, it's a little bit different. In geometry, we label points. So this would be label A. And we would call that point A. A point is a location. Over here for line, well, I'm just going to draw another line. But I have no coordinates, so I have no way of giving it values in terms of an equation. But what I'll do instead is it takes 2 points to define a line. So you need at least 2 points on it. We're going to call them P and Q. Or sometimes in geometry, we just name a line. So what could I call this? Well, I could call this line M. I could also call it line PQ with this sign over it. That tells us it's a line. And I could call it line QP. Wait, that's different, right? Yes, you must put the arrows on each end. The arrows on each end tells it it's a line because lines go forever in both directions. If you only put one arrow or put no arrows, that means two different things that we're going to find out in days to come. Notice also, though, the order didn't matter. We could change the order of which we listed these to define the line. So we define it. And what is a line? It is made up of points. And last, we're going to talk about a plane. Now, just go ahead and draw this with me. Dot, B, C, D. And this is a plane. This is plane K. Ever see a plane labeled with a letter that doesn't have an associated point with it? It's just a plane. That's the name of the plane. What else could I call this? I could call this plane BCD. I could call this plane DCB. Or I'd call this plane CDB. I hope you're seeing that any combination of those three. Important things are this. We define a plane with three non-collinear points. Big word, 2L should be. Collinear points. Collinear points, so I'm going to write this down here. Collinear just means on the same line. So for example, P and Q are collinear. And really, if you look at B, C, or D, I could draw a line through any two of them that are collinear, but all three of them are not collinear. There has to be at least one that's not collinear, okay? So 3 non-collinear points. And what else do we know about a plane? Flat surface. Made up of points. Extending in every direction. All right. Got a lot of writing there. Go ahead and take a moment, please. Pause this. I'm going to get moving here in about 3. All right. So I'm assuming you've paused it, written down what you need to write down, and we're going to move on to the back side of this paper. And what does this say right here? Use the diagram below, talking about this diagram right here, to answer the following questions. The line, we see this line here, right? It's easier to see if you're looking at your own paper, but the line can be named line C or using any two of the points on the plane, or on the line, excuse me, on the line. So name the line containing the points Q. Believe it or not, I could call it line C, right? We already said that. It also could be TQ or QT, QT. Or it could be RQ. Or if not RQ, it could be QR. Okay, the reason we didn't use the B or the V right here, guys, is because that picture is like of this plane right here, this paper, and that BV line is coming up through the bottom and coming out the other end. So it's not in the plane, except for that, where it hits at R right there, right? So now we're going to talk about naming the plane. One plane that can be named is plane A. We see that letter down there with no associated point, so it's plane A. You can also use the letters of any 3, we already said this, non-collinear points on the plane. What is another correct name for plane A? Well, I could call it plane STR, right? Because S isn't linear. T and R are on the same line, but S isn't, so we've made a triangle. Basically, we're just making a triangle. And why do I say that? If we're defining a plane by 3 points, think about this. What do 3 points make? They make a triangle. And that triangle extends in every generation. Even though we usually use rectangles or squares to define a plane, it's really 3 points to define it, which form a triangle. Which makes sense. A point is a point, right? That takes 1 point to define it. How many points to define a line? 2. So it makes sense, going with that math, it would take 3 points to define a plane. Okay? And that's what we're doing. So we have plane STR. What else can I use? I can use plane QRT, or excuse me, QRS. I'd already written the QRS. I couldn't do QRT because QRT are collinear. It has to be 3 non-collinear points. So we need at least one that makes the triangle. I could name it plane QTS. And I could do any combination of these. So I could do plane, just rearrange those letters, RST. Same with here, SRQ. You know, just rearrange them as you're able to make different. There are all ways of naming the same plane. So why don't you take a minute and list the names that you could call this plane for number 1 and names that you could call the line containing the point E. Ready, set, go. Okay, I'm assuming you pause it if you need to, but list names indicating plane. Well, we could call this plane X, right? Because there's a big X down here. Could also call it plane FDB. Or any combination of those letters, or plane FDE. Or any combination of those letters. You can do plane FBE, and any combination of those letters. However, what you need to know is every time I needed F, just like every time I needed S up here, because that is a point that is non-collinear to the other two. All right? Okay, let's talk about naming the line containing point E. Okay, well, I could have, make sure put that line symbol. Line BE, line DE, line EB, or line, I'll throw it out line ED. Okay, those are 4 possible names for that line. Awesome. Let's finish up. We're almost done. Looking down here, this is a real confusing looking question. Take a minute and read this question. Pause it, read it. Okay, I'm assuming you paused it and read it. It says, this looks confusing, but it's going to be so easy. Line A, B, and DC, and line DC lie on the coordinate plane. All right, they do, that's true. For A is 4, 6. Let's go ahead and label it 4, 6. B is -1, -6. C is 7, 3. And D is -5, -1. Point G is collinear with line AB and line DC. Well, what point G? There is no point G. Oh, draw point G so that it meets the above criteria. Well, point G is collinear with AB, so I need to draw a point that's on AB to be collinear with it. But it also has to be collinear with line DC. There's only one space where I could draw a point that is linear with both those lines, and that's where they intersect. And that is point G. Boom! That's it for today. Lines or points, lines, and planes. Go crush the horde. Peace out.